All right, here are the answers to those monitoring progress questions. So check those, make sure you got them correct, and then can move on to the rest of the notes. So the product property of radicals, we talked about this in 4.1a. If we have the square root of a times b, then we have the square root of a times the square root of b, where a and b are greater than or equal to 0. Now the quotient property, we also talked in 4.1a about this. If you have the square root of a divided by b, that's the same as the square root of a divided by the square root of b, where a is greater than or equal to 0 and b is greater than 0, right? It can't be equal to 0 because you can't divide by 0. Okay, so let's do some examples. So for number 5, we're doing 2 root 5 times root 10. So we can use our product property and know that if we have two separate radicals, then we can multiply under one radical. So 5 times 10 is going to be 50. So we have 2 root 50, and then we need to simplify. So 50 is 5 times 10. 10 is 5 times 2, and that's as far as those will break down. So we have one group of 2 5s and one 2 that's going to stay underneath. So we're going to get a 5 on the outside, a 2 underneath, and then we still have this 2 that was already on the outside. So 2 times 5 is 10 root 2. All right, let's do another example. So for this, we have the square root of 2 times 3 root 2 minus root 6. So all we're going to do is distribute into our parentheses. So we're going to do 3 root 2 times root 2 minus root 6 times root 2. And again, because of our product property, we can say that that's just multiplying underneath the radical. So 2 times 2 is 4, so we have 3 root 4, minus 6 times 2 is 12, so minus root 12. Well, the square root of 4 is just 2, right? 2 times 2 is 4. Now the square root of 12, let's break it down. We have 4 times 3, and our 4 will be 2 times 2. So we have one group of 2's to pull outside, and then one 3 to stay underneath. So our final answer, 3 times 2 is 6, minus 2 root 3. And that's our answer for number 6. Okay, let's look at number 7. So this is the quotient property. So we know that if we have the square root over the whole thing, it's equal to the square root over the top and the square root over the bottom. Okay, so now we just need to do these separately. So first let's look at the square root of 12x. Well, 12 we can break down to 4 times 3, and 4 is 2 times 2. So we have 1 2 on the outside, we have a 3 left inside. Then we also have that x. There's only one x, so it's going to stay on the inside because it doesn't have a pair to come outside. Okay, and then we have the square root of 16y squared. Now 16 is 4 times 4, and 4 is 2 times 2. So we have two groups of 2, so we can pull a 2 out for each of those. And then y squared is y times y, so we have a group of 2 y's, so we can also pull a y out. So that's going to be 4y, right? 2 times 2 is y. And then we can simplify that because 2 divided by 4 will be 1/2, so we'll just have 2y on the bottom. And that's our answer for number 7. All right, let's look at number 8. So again, we're just going to distribute this inside our parentheses. So we have the cubed root of negative 4 times 2, right? We can put them under the same root, minus the cubed root of negative 4 times 16. So negative 4 times 2 is negative 8. Negative 4 times 16 is negative 64. And now we need to factor these. So negative 8, we pull out the negative 1. And then 8 is 4 times 2. And 4 is 2 times 2. Okay, and since we're doing a cubed root, we're looking for groups of 3. So we have 3 2's and our negative to pull outside. So the cubed root of negative 8 is negative 2. Now we're going to break down our negative 64. So pull out negative 1. And then 64, that will be 8 times 8. 8 is 4 times 2. And then 4 is 2 times 2. So again, we have 2 groups of 3 2's. So that's going to be 2 times 2. And then we have our negative. So that one's negative 4. So we have negative 2 minus our negative 4. So that's negative 2 plus 4, which is 2. And that's the answer for number 8.